Matthias is here, your trusted advisor. Today we will have a deeper look into notebooks in Microsoft Fabric. So let's just start with the most obvious question. Hey, I have a notebook that runs perfectly in interactive mode. I schedule it, I use it on 1,000 rows, it works. I use it on 10 million rows, and suddenly the performance is really, really bad. What can be the reason? The reason is in the notebook architecture and Fabric. Let's go a little bit deeper and let's discuss. So how about the notebook execution architecture? When you have a look at the notebook execution architecture, so this is notebook execution architecture. Oh, I didn't mention, by the way, the Fabric periodic table. Let's go there because you have a really nice overview on the notebook topic with all the key features listed, different use cases, different scenarios, with lakehouse, notebooks, visualizations, and so on. The scheduled jobs we will talk about later, some naming conventions, Fabric CLI, further resources and licensing. So I think that's really worth a look. But let's go back. Notebook execution architecture. So first we have our notebook here, right? Note. A notebook is you have cells in a notebook. The cells can be Markdown, which is simply text, or code. So we are currently talking about the code cells, obviously. The notebook is part of your Fabric workspace, right? So you have the Fabric workspace here. So notebook is part of that. And inside of that notebook, you have a cell. Let's say you have a cell 1 that starts with %, PySpark. Then this PySpark cell will be, this is part of the notebook, right? Like this, will be executed in a distributed way. The distributed way means that you have, oh, that wasn't an improvement. So let's try that better way. So the distributed way means distributed. This cell will be executed in a distributed way. What exactly does distributed mean? You have your Spark session. We will talk about sessions in a minute, but just think about it's like a session that you start when you run Spark code. You need some executor. This is the execution environment, Spark session, where your code runs. And inside of that Spark session, you have two different nodes. The first one is the so-called driver node. The driver node is like the orchestrator of the executor nodes. These are the other ones. So the executor nodes, you can have more, right? So let's say you have 4, executor node 1, executor node 2, executor node 3, and executor node 4. Different executors, all part of the overall executor cluster. And there we go. So distributed means that your Spark session uses the executor cluster. So this is executed by the executor cluster, which means you have scaling. When you start your second cell, the cell 2, with % SQL, then again, this runs distributed. distributed. So this is executed by your executors environment. When you run the third cell, the 3 with %, Python. So, and here we go. When you run it with %, Python, then this is executed only with the driver node. This means when you use %, Python, so use Python code, then you have only one executor here, which obviously makes things much, much slower. At the end of all that, you will end up in a lakehouse, typically lakehouse, either in the tables or in the files folder. So, but this is the magic here. It's called magic command, by the way. So the first 2 are distributed. The last one, the Python one, runs only on the driver node, which is okay when you have not so much data, right? That's absolutely fine. So Python runs only on the driver. It's fast, but it doesn't scale. PySpark distributes to all the executors. It's much faster, but you have the overhead. So there can be very good reasons to just use the Python magic command. The second thing that impacts your performance is the consideration whether you want to use a starter pool for execution versus your custom environment. Right? So obviously custom environment means more degrees of freedom. You can configure more stuff. Starter pool means some stuff is predefined. So it starts all with the action that the user clicks run. So then there is an environment check. The environment checks which kind of environment should be used. Is it either a cold start or is it a hot start or warm start? So let's say this is a custom environment. When this is a custom environment, that means that there is a cold start. You need to provision, or Fabric needs to provision the cluster. This is some kind of work. Even in a Fabric world, you can expect something like roughly 3 to 5 minutes for that. After that, you will typically run something with custom libraries. Custom libraries, they need to be installed. This also takes, again, some time. Depends on the number of libraries, something between 2 to 10 minutes in addition. So this is plus. And after that, your session is ready. So this is great then, but as you can imagine, this is quite a way to go, right? Something between 5 to 15 minutes to get all that up and running. This is a custom environment. When you compare that with starter pool, means user clicks run. I will abbreviate that a little bit. There's a check. Same behavior. Now the check says, hey, we will use the starter pool. The starter pool is already warmed up by Microsoft. So that means there's a warm cluster. It's already running. So you need simply a session assignment. This takes between 10 to 30 seconds. And then your session is ready. It's much faster using the starter pool. So the trade-off is you have a shared environment and shared resources, and you have limited customizations. So use the starter pool when you are fine with standard libraries and you don't need any very special libraries. When you are fine with interactive exploration versus production workloads, because production workloads usually run for a longer time, so it's acceptable to have some startup time. When you have fast iteration parity versus reproducibility required regarding performance and so on. So this is one of the decisions you will need to make. So let's run the cell one time on the standard environment and one time on our custom environment. So this is a very simple print hello world, but you will see even there's a very small difference of 2 seconds. This is a run with a custom environment. I didn't load any heavy custom libraries, so this is okay, but still you see that even for very simple tasks, there's some overhead, which is okay. We have already learned that you have the magic commands, and the magic commands have some impact on how fast something is executed regarding the startup times, so the overhead, and how fast is something executed during the runtime. So let's go a little bit deeper into that, the so-called language execution mode, or LEX, language execution modes. So you have your notebook cell, obviously, notebook cell, and then you have different execution modes. The first one is %, PySpark. This runs PySpark, obviously. Means, for example, you would write data frame equals spark.read, and so on. This executes in the Spark cluster. These are the executors, and it means longer startup in general, because distribution overhead. So you have overhead, but you have parallel execution. So this is running in the Spark cluster. Second one, %, SQL, would mean select asterisk from, you name it, is also executed in your Spark cluster. So same thing. You have %, scalar, scalar. This is also executed in the cluster. And you have %, %r, if you need r. This is also executed in the cluster. The only thing that is executed in the driver node only is %, Python. Would start with import requests or something like that. So that's a big difference. Python cells don't scale, but you can use it for control flow, for APIs, for small data. PySpark distributes the work. But of course, if you just need a REST call, if you just need to deal around with 10 megabytes of data, then you don't need the overhead of parallelization there. That's the point. So both is fine. You just need to be aware what are the consequences on your selection. So this is all about the difference between Spark and Python. The magic commands, Python driver and the PySpark driver. The first code is about processing a bunch of rows in Python. The second part is about processing the same amount of rows in PySpark. And so I started the code. So it creates the Spark jobs in behind, and you see there is some grouping and some summing and some order by done on the rows. These are the jobs running here. And you see we took about 500,000 of rows, and it took 0.004 seconds on pandas, and PySpark took nearly a second, but the two pandas operation took about 5 seconds. This is the very, very main stuff here. Next one is that we go to the SQL magic command and run some SQL code here, just inline, and it creates a data frame, which is honestly amazing. So you can mix up Python and SQL, and it's great. It's looking great. It's working great. And there you see all your data in just a second with your favorite language mix. So how is the journey from notebook writing to notebook production? So your notebook is interactive. You start writing a notebook. But how about getting your notebook ready to production? What are your options? So there we go. You first usually start with development. So this is the first step. And in that development, you will execute your notebook typically in an interactive way. So we'll run a cell, use the result, change your code, rerun the cell, and so on. So this is interactive. Once this interactive notebook runs in a way that you want it, then you can use it for testing, for example, right? So next step after development is testing. Typically there you would use a scheduled notebook. So same notebook, but scheduled, right? So the interactive mode is perfect for development. The next one then is testing. There you can schedule that. And after that, you could extract to .py, which means you would create for production a Spark job definition. Spark job definition, like that. So this is perfect for production because you don't have all the overhead of interactivity in a notebook. So when would you need this interactivity? So to explore, to iterate, or to visualize. For testing, for scheduling notebooks, you would need that for parameterize, for schedule, and for validation. And the production idea, of course, is as always to be robust, to be monitored, and to be versioned. These are the 3 main points here. Right? So this is your development to production journey. So it's absolutely fine to start interactive, to use it for testing, and then bring it to production as a Spark job definition. So one of the key points is notebooks are for humans. Production needs machines, means Spark job definitions, but you have different orchestration options. So let's have a look into your different orchestration options. The option one is built-in schedule. You can simply schedule a notebook, right? So you have your notebook. You say, okay, please run a daily at 6 a.m. and it will simply run, right? So this is great. This is great for simple recurring runs, but as you can see, you don't have any logic here, right? It's just execute. That's it. When you need it a little bit more sophisticated, you can embed in option 2, pipeline. You get the idea? You can embed your notebook into a pipeline. So in the pipeline, you have the pipeline trigger first that kicks off the pipeline. Then you have, let's say, a copy activity. Very typical. Then you have your notebook activity. Then you might have the next notebook activity. And then you might have, let's say, something like a data flow activity. Right? And so these both you can use right in the pipeline. So pipeline is very, very handy, and you have more control. You can prepare the stuff in a more sophisticated way. But you have third option. Third option would be option 3, Spark job. So option 3, you have again the pipeline trigger. Then you have the Spark job definition activity in the pipeline. So this is your job here, right? There we go. And that means that main.py is executed as batch. There we go. So when to use what? Built-in schedule, simple, straightforward. Data pipeline for more complex orchestration with some dependencies. Spark job definition for production, batch jobs to reduce the overhead as much as possible. You might think notebooks are all about code, but this is not true. We have a very nice extension which is called Data Wrangler. The Data Wrangler extension is really cool because it integrates with your code, and you can use it as an entry point to get a little bit used to notebooks, and it emits codes, so you can then work directly on the code. So how is it basically designed? In the Data Wrangler UI, you have column profiles. You have operations like filter, sort, group, and you have data preview. And all that generates code, right? So how does it fit into the notebook? You have the notebook here. Cell 1 is load data. Means data frame equals something. Cell 2 says launch Data Wrangler. So there you go here. And after you went through all the configuration in the user interface, you add that back to the notebook, which means cell 3 equals your generated code from the Data Wrangler. So this is a point. You can do it in the UI, but later on you can continue to work if you want in code. So while writing all the transformations from scratch is pretty hard for beginners. So Microsoft has created UI for that. So you have point and click operations, and you see what your point and click produces, because you will end up with PySpark code right here. So you can learn from it, and when you have simple modifications, you can just go straight to the code, and over time you might start directly with writing code. So this is about data Wrangler. I have generated some sample code here. This is AI generated, as you can see, so that we have a data frame pre-filled. So this runs, and once this is working, or this was running, so we see it here, variables are pre-filled. We can go to the data Wrangler, pick the data frame that you want to work on. We have on the left side a lot of operations that we can pick. We have some helpful statistics here with distinct values, missing values, and so on. In the middle, you have a Copilot that you can use, and on the bottom left, you see the different applied steps. So I can add a sorting, I can add a filter. So I have added a sorting here, and I have filter options, and I have formulas and all that stuff. And you see it's a very visual way to work with your data, so you can filter on one person ID and so on. But you can also jump over and go to Copilot and say, please filter the top 50. Let's take something different, records, and there we go. It's working on it. That's the code, and now you have a mixture between the order date and our new operation that we can accept. And next we can go back. So you see we have the two actions here. We can go back and add the code to the notebook. That's the magic here. So we can simply hit add, and this is the code generated by the data Wrangler for the Python data frame, with all the operations we created with the Copilot and with the GUI. And this is our result, and I think it's pretty amazing. When you start a notebook, you might have noticed that a session is started for you. So just imagine you have about 20 people working with Python notebooks. Then you will end up with 20 sessions, which consumes a bunch of resources. So this is a so-called standard mode. Standard modes means you have user A has session 1, user B has session 2, and so on. You can imagine. When you go to the so-called high concurrency mode, then you have user A, user B, and user C, and they all share the same shared session. Of course, you need more RAM, but you will end up with lower costs. So this cost is like 3 times, and this cost is like 1 time, right? The trade-off then is, if one user consumes the resources, then the other ones will be affected. And you're working in a shared environment, so when you have some very sensitive data, that might be something that you want to prohibit. But you will bring down the costs with the high concurrency mode because essentially you use a shared environment. The community question. First and most common question is from Reddit. 67 upvotes. Why is my notebook so slow to start? Every time I open a notebook, I wait 5+ minutes before I can run anything. This is killing my productivity. The answer is check if you are using a custom environment instead of a starter pool. Here's why. Starter pools are pre-warmed clusters. They start in around 30 seconds. Custom environments need to provision a new cluster, install your libraries. When you have complex libraries, then this can take up to 5 minutes. So check whether you can go with a starter pool or pull out some complex library dependencies if possible. Question 2. Person Python versus person PySpark. When to use which? So I see both the Python magic command and the PySpark magic command. What's the difference? Well, great question. This is a very common question, 52 upvotes, by the way. So PySpark commands are distributed across several nodes. So you have more complexity in setting these things in the background up, so that you have some overhead, not on your side, but for the sake of time. But when it's up and running, it's blazingly fast. Python magic command code just only on the driver node. So standard Python, no Spark overhead. Why do you have both? Because you have tasks like calling a REST API that don't need a cluster. Pandas for 1,000 rows don't need distribution. So the PySpark magic command could be overhead for some tasks. Question 3. How do I share variables between notebooks? I have a notebook A that calculates a value, a notebook B that meets the value. How do I pass it? 3 approaches. So first one, notebook utils.notebook.run with a return value. So you can give a return value from your notebook. Option 2 is writing to a table, for example, a lakehouse table. Option 3 is pipeline parameters. So you can run both notebooks within the pipeline, and then you can pass the pipeline parameters between the notebooks and write them in different notebooks. Next question, can I debug Fabric notebooks like I can debug regular Python? So I'm used to setting breakpoints in VS Code. Can I do the same in Fabric notebooks? Yes, there is a VS Code extension for Microsoft Fabric. You can install it, you can connect to your workspace, you can then open your notebook locally, you can set breakpoints, and you can use your debugger. So the web editor is great for quick fixes and so on, but for serious debugging, well, VS Code is great. Make it simple. My notebook ran fine, but now I get out of memory errors. I have a notebook that worked last week. Now it fails with out of memory. Data hasn't changed. What's happening? So most common causes, you might have accumulated state from previous cells. Could happen. Right, a lot of data frames that are cached, so you need to unpersist them or restart the kernel. You can do collect on large data, so this can erase all of memory stuff. All the Python variables are accumulating, so the fix is then processed in chunks and write intermediate results out. Very common. How do I install a custom library? I need to use, let's say, great expectations in my notebook, but it's not pre-installed. What's the best way? 3 options. First, inline install. Pip install great expectations. Fast for testing, but you have to do it in every session. Next option, custom environment. You know the trade-off is it's a little bit slower in startup. Option 3 would be use a workspace library. So you can upload a VHL file to your workspace, and then it's available to all notebooks. Next problem. My notebook works perfectly alone, but it fails in a pipeline. So why? First one, could be missing parameters. So interactive, your hard-coded values during development pipeline expect some parameters, so that could be an issue. Interactive, it always runs as you. In pipeline, it could run, if it's configured, as a service principal, so it might be a permission issue, different identity. Or you have relative paths, right? Interactive, you are in the notebook folder, pipeline, as the working directory might differ, so check for relative paths. So what helps always is kind of add logging, so write stuff out, of course no sensitive data, but everything else, so you get an idea what's going on. I do that a lot. I like it. So there are some misconceptions too. Notebooks are only for data scientists. Yeah, and no, you have great tools like Data Wrangler that you can use to explore notebooks even without writing one line of code. Misconception, magic command Python is always slower than magic command PySpark. No, we talked about that already, I think. Misconception, notebooks cannot be used in production. Well, you can schedule notebooks, you can run notebooks from pipelines. For heavy workloads, just extract Spark job definitions and you are fine. Misconception, Data Wrangler is only for beginners. No, it's fast, and when you are faster with Data Wrangler, that's absolutely fine. This time everything was about notebooks, and I hope you enjoyed it. It's a little bit theoretical, it's a little bit more code, but it's really, really powerful. And I think you have got a lot of practical and architectural and community-wise input. If you want to get notified when I release my next video, please hit subscribe on that YouTube channel. See you next time. Thank you.